to my limit series. Today, we will prove a property about derivatives, and that is the following. That the derivative with respect to x of a function of x is equal to 0 if f of x is equal to a constant. Let's call this constant c. And this is true for all c in the real numbers. So essentially what this means is if our function is a constant, then for all inputs in our function, the derivative with respect to that input is equal to 0. And I can draw a graph of this. This should be easy to kind of conceptually understand, where this is our x, this is our y, and then f of x, if it's a constant, it's just going to look like a straight line. So therefore, the slope of this straight line is always going to be 0. Of course, proving this will be a whole other task altogether. So let's take a look at how we would prove it. First of all, let's look at the limit definition of our derivative here. So we're looking at the limit as h approaches 0 of f of x. So I'll just write before converting. So we have our f of x plus h minus f of x, all divided by h. Now, of course, we can make substitutions. So f of x is equal to c. F of x plus h is also equal to c. So we can rewrite the following as the limit as h approaches 0 of c minus c over h. So that's the same thing as the limit as h approaches 0 of 0 divided by h. So I just want to make it clear, all I've done is simplify what's on the inside, right? So because what's on the inside is equal, the limit as h approaches 0 of all these things should be equal. Now, of course, 0 divided by anything is 0, except that h is approaching 0, so we might not feel the most comfortable plugging in 0 for h and just concluding that 0 because we get a 0 over 0 case. However, we can prove this using the definition of a limit. So we want to show that the limit as h approaches 0 of 0 divided by h is equal to 0. So what does this mean? Well, using the definition of our limit, for all epsilon greater than 0, there exists a positive delta such that for all h, because h is the thing that's doing approaching, so whenever h is within delta of 0, so 0 is less than the absolute value of h minus 0, which is less than our delta, that this implies the following, that our function, which in this case is 0 divided by h, minus the limit, so 0, is less than epsilon. So let's think about how we can show this. First, let's just show that this works for a delta. So let's suppose that delta is equal to epsilon. Let's just make that easy. Now let's think about what our condition for h is. We have now that the absolute value of h minus 0 is greater than 0. So 0 is less than the absolute value of h. In other words, this here implies that h cannot equal 0. Because if h was 0, then we would get 0 is less than 0. That would not be true. However, if h doesn't equal 0, this implies that 0 divided by h is equal to 0, right? Because if h isn't 0, what's in our denominator is not 0. And 0 divided by anything, right? Any real number that could be in a denominator. So 0 divided by anything that isn't 0 must be 0. So that means that what we have right here are 0 divided by h is actually equal to 0, which means we get 0 is less than epsilon, which, well, of course it is, by definition. Epsilon is positive. So therefore, this limit is equal to 0. Therefore, if our function is a constant, then the derivative of that function at any point x, no matter what that constant is even equal to, must be 0. Thank you very much for watching.